Kia ora Year 12. Here's a really nice little polar form excellence question from back in 2012. Again, this is exactly the kind of thing that could still pop up. So we've got Z is, we're told to write Z in polar form. Oops, wrong pen. And we have to prove that for positive values of n, that this is always real if the magnitude of Z is equal to 1. Okay, so let's write Z is equal to r cis theta, but we know the magnitude is 1. So since magnitude is 1, oh, I don't know what's happened there. There we go. So Z is equal to cis theta. Now we're going to use de Moivre's theorem in here. So we've got Z to the power of n, which is cis theta to the power of n, which is cis of n theta. And Z to the negative n is cis theta to the negative n, which is cis negative n theta. Now, we're assuming there that de Moivre's theorem works for negative numbers. It does. You could do a bit more work to show this without making that assumption by just writing Z to the negative n as 1 over Z to the n and proceeding from there, and you will get there. But that's a whole lot more work than was required. So we're safe to assume here that de Moivre's works for both positive and negative integer values. So what does that give me? Well, we've got to work with Z to the n plus Z to the negative n, and our job is to show that it is real. Okay, so we're going to add these two things together. So we'll start by writing it in abbreviated form. And now we're going to apply the definition of cis theta. So that's cos of n theta plus I sine of n theta plus cos of negative n theta plus I sine of negative n theta. Now, pretty sure I made a bet with someone last week that odd and even functions would come up in scholarship. This isn't scholarship, but we've got odd and even functions right now. So I'm going to do this really slowly because it's a proved question. I've got cos n theta plus cos of negative n theta for my real bit plus I times sine of n theta plus sine of negative n theta. So since cos of negative x equals cos of x, even function, and sine of negative x equals negative sine x, odd function, we can write this equals cos n theta plus cos n theta, and you know the rest. So you're not even watching now, but that's okay. Sine n theta minus sine of n theta, which is 2 cos of n theta. So we've shown that z plus n, z to the negative n, is purely real.